So this is my flip video or the prep video today for on differentiation rules. Now so far, like yesterday, we learned that if you want to find the derivative function, right, of a function, then you want to find the derivative as a function, then you really need to use the limit definition, right? Okay, which is f prime x equals limit h tends to 0 f of x plus h minus f of x over h. So if you want to find as a function, then you put x here. If you want to find the derivative at 2, then you put 2 here. If you want to find the derivative at 3, you put 3 here, and so on. But however, if you want, every time if you want to differentiate a function, if you had to use this definition, it is going to be very painful and it's going to be very arduous. Okay, so we need some shortcuts. Okay, so for routing differentiation methods, there are a number of rules that you can use, which are very nice and easy shortcuts. Now, in an exam or a quiz, if I tell you to use the limit definition, you must use the limit definition. If I don't tell you, then you can use any one of those rules. So let's look at the first rule. Now first, if the function is a constant function, so what do you mean by that? If the function is equal to say 7 or 6, right, then the derivative is 0. And why is that? Because the constant function is a straight line, right? I mean, it's a horizontal straight line and there is no change. Now I remember I told you that the derivative is the rate of change. So if there is no change, then the derivative is 0. The rate is 0 because it's a flat line. Okay, so therefore the derivative is 0. So for example, if the function is f of x equals 5, then the derivative of f is equal to 0. Or f of x equals 7, or f of x equals 8 or 9 or pi or e or anything, as long as it is constant, right? Okay, the derivative is 0. The second most important rule is the power rule. Now let's spend some time on that. If your function is just a simple power of x, right, to find the derivative is very easy. What you do is you bring the power forward. So you bring this power forward, okay, and then you write x and you subtract 1 from the power, so n minus 1. So for example, take this example, x to the 5. Okay, so if we have x to the 5, then the derivative would be the 5 goes to the front, so 5, and then x, and then you subtract 1 from the 5, making it 4. So it's 5x to the 4. Another example, suppose this is 7, say x to the 7, then what will it be? Then it will be 7x and the 7 will become 6. If it is x to the 8, then it will be 8x, right? And then, okay, x to the 7. If it's 8x to the 8, then it will be what? 8 comes up in front, 8x, and the 8 will become 7, and you get 8x to the 7. This can be used not only for positive powers, it can also be used for weird powers like radicals. For example, if you have f of x equals square root of x, then square root of x is actually the 1/2's power. If you differentiate that, then what do you think will happen? The same thing, okay? The 1/2 will come forward, so we have 1/2 and x, and then you subtract 1 from 1/2. So what happens when you subtract 1 from 1/2? That becomes negative 1/2. So you get x to the negative 1/2. Now we don't really use you leave your answer as negative powers, right? Okay, so you want to convert this into a positive power, right? So it's 1 over 2, and x to the 1/2 is just 1 over x to the half, right? So it's actually, so if I want to do that extra step here, it will be sorry, so it will be right, so we 1/2, then it will be 1 over, so 1 over the 1/2, and then you have x to the power 1/2, right? I mean, because this negative 1/2 becomes 1 over x to the positive 1/2, but we know that x to the 1/2 is square root x, so it's 1 over 2 square root x. Okay, let's take another example. If you take f of x equals 1 over x, now 1 over x, right, is also power of x. Which power? 1 over x is equal to x to the minus 1. So if you take the derivative of that, then what do you think will happen? This negative 1 minus 1 right here will come to the front. Okay, so negative 1 will come to the front. Can you see that? And you will have x and x, and then what happens to the power? You subtract 1. So if you subtract 1 from negative 1, you get what? Negative 2. So negative x to the negative 2, which is equal to, then you have the negative is still there, but then you don't leave the answer. This is the answer, though you don't leave it in that form. You need to kind of clean it up. So x to the negative 2 is the same as what? 1 over x to the 2. You need to leave it as a positive power. So that's the power rule, guys. So once again, power rule is when you have power, you bring the power forward and you subtract 1 from x. So 5x, x to the 5 becomes 5x 4, x to the 1 half becomes 1 half x to the negative 1 half. And if you have a power like 1 over something, right, okay, then it's x to the negative 1. So f prime x is negative 1 x to the negative 2. So for example, if you take 1 over x squared here, if you have x squared here, what do you think will happen? Well, x squared is the same as x to the negative 2, so the negative 2 will come up in front, right? So if I put, say for example, x squared here, right, okay, and then what will happen? Then that's negative 2, and then that will become what? The negative 2 will come in front, that will become negative 2, and the negative 2 will subtract 1, so that will become what? Negative 3, and then if I clean this up, right, okay, then this will become, the negative 2 is still on top, but then this 2 will become 3, as x to the negative 3 will become x 1 over x to the positive 3. Is that okay? All right, so that's the power rule. Okay, power rule. All right, now the next rule we are going to do is, now remember when you had a constant by itself, okay, like f of x equals 5, that's a constant by itself, then the derivative is 0. But if you have a constant multiple, then the rule is different. If you have a constant multiple of a function, then you just leave the constant alone and differentiate the function. So let's try to see what it's meant by that. So if you take, for example, if you have 3 times x to the 7, so then it's a constant times x to the 7, right? So leave the constant alone. So what happens? You can, it's kind of like taking the constant outside the derivative sign. So you have 3, right, times you differentiate the rest. So dx to the 7 over dx. All right. So once again, right, the d over dx, okay, is another way. Well, I didn't tell you at the very beginning that d over dx is actually another way of writing the derivative. Okay, all right, and so 3 times, then what's the derivative of x to the 7? That is what? 7x to the 6. All right, so now the 3 is still there, so 3 times 7, 21, x to the, oh I'm sorry, this is typo here, so 6. Okay, very good. That's the constant multiple rule. So if you had 4x to the 7 there, then what will that will be? Then the 4 will be taken out, so this will be 4, and the rest will be the same. All right. Now the last rule that I'm going to teach you is the sum rule. That means if you have the sum of two functions, it's very easy to differentiate this, right? The derivative of the sum is the sum of the derivatives. Okay, so the derivative of sum as a sum of the derivatives, right? Okay, and so how do you, let's look at an application of that. So we have, suppose we need to differentiate this function, right? Okay, so it has 3 pieces, right? Piece 1, piece 2, piece 3, joined by a sum. What you do is you take each piece at a time and differentiate them separately. So you differentiate 2x to the 7 separately, you differentiate 2 this separately, in which case you can actually take the 2 outside. Why is that? Because in the previous thing we saw that if you have a constant you can take it outside, so 2 comes outside, you need to differentiate square root x over dx, and then you need to differentiate 7. So if you go further, then you can take the 2 outside from this, right, and then you have 2 is taken outside, and the derivative of x to the 7 would be what? 7 times x to the 6, so 7 times x to the 6, and then we have 2 here, so 2 here, and then what's the derivative of square root x? In the previous example we learned that the derivative of square root x is actually 1 over 2 square root x. So we can put that here. So 1 over, so this is that part, 1 over 2 square root x, right? This 2 is from the 2 here, okay? Alright, so it's 2 times 1 over, right? Okay, 2 square root x. So alright, okay, and so actually this part is the derivative of the square root x. So 1 over 2 square root x, and then you have, finally you have this part, the derivative of 7. Derivative of 7 is a constant by itself, not a constant multiple, but a constant by itself, and the derivative is 0. The final answer will be 2 times 7 is 14 times x to the 6. 2 and the 2 will cancel off here, right? Okay, so this 2 will cancel off with this 2, leaving what? Leaving 1 over square root x behind, and then plus 0 is plus 0. The last example, let's look at to find the derivative of a polynomial. So we have a polynomial here, say y, right? Suppose we want to find the derivative, so then we write it as dy over dx. Why is that? Because y is the function now, right? So dy over dx is equal to, so once again we have a sum. So let's differentiate piece by piece, okay? So what's the derivative of the first piece? X to the 5, it's 5x to the 4, okay? What's the derivative of the second piece? Now you can see a constant multiple here, right? So we leave the 2 alone, and then we differentiate the 4, we get what? 2 times 4x to the 3. 2 times 4x to the 3, so 2 times 4 is 8. So 8x to the 3, is that okay? And then we have once again a thing. So what's the derivative of 3x? So 3 is a constant, so we leave 3 at alone. And how do you differentiate x? Well, this is something easy to remember. The derivative of x is 1. How do you do that? Because 1 comes up in front, okay? Alright, so let me just if I want to highlight that, I mean, let's do a small thing. I mean, if I want to differentiate say d over dx of x, right? Okay, that's right. Uh, okay, so d over dx of x, right, is like x to the 1, so it's like d over dx of x to the power 1, right? Okay, and right, and how do you do that? You bring the 1 forward, so 1 comes forward, and then x to the power, you take off 1, so 1 comes forward, then x to the power 1 minus 1 is 0. So 1 times, what is x to the 0? Well, x to the 0 is 1. 0 to the power, any number to the power of 0 is 1. So 1. So remember that, so this is a side result, right? The derivative of x is 1. So then the derivative of 3x will be 3 times 1. Okay, so 3 times 1, right? So derivative of 4x will be 4 times 1. Then go to the last piece, then we have 6 here. So derivative of 6 is just 0. Why? Because it's a constant by itself. As the last example, let me do another problem like this. You want to find the equation to the line tangent to this curve. So we have a curve, we want to find the equation of the tangent line. Now, a tangent line is a straight line. So any equation of the straight line can be written in the point slope form as y minus y1 equals m times x minus x1. You learned that in college algebra or wherever. Where x1 and y1 are a point on the curve. And what is m? Now the important thing here is m is the slope of the tangent. But we know what the slope of the tangent is. The slope of the tangent is nothing but the derivative. But we know how to find the derivative now. The function is a square root function. So if you use the power rule, then we saw somewhere here, right? Okay, that the derivative is 1 over 2 square root x. So therefore, the slope or m is actually 1 over 2 square root x. But you need to put the value of x. So you need to put 4 there. And then you get 1 over 2 square root 4. So square root 4 is 2, right? So 2 times 2, so which is 1 over 4, right? Okay. So once again, this is the slope of the tangent, which is nothing but the derivative. So you calculate the derivative of square root x using the power rule, and you should get this. And then you plug in the value of x, then you should get 1/4. So that is 1/4. That much we know, right? What about x1 and y1? Well, x1 is the point, which is 4 on the curve, and y1 you can get by just plugging in 4 here, so that you can get the y value at that point. Not the derivative, but the original function, right? So the original function is square root x. So you plug in 4 there, you get square root 4, which is 2. So now it's a matter of plugging in, and you put y minus, I'm sorry, this is y minus y1 is 2. Okay, so y minus 2 is equal to what is m? M is 1/4 x minus x1. x1 is what? 4. All right, now you got the equation. This is the equation. This is fine. But for simplification purposes, we need to distribute this. So you have y minus 2 is equal to 1/4 x minus 1/4 times 4. So you distribute this inside, you get 1/4 x. Distribute this inside, you get 1/4 4, 1 minus 2. So if you go down further, y minus 2, this is 1/4 x, and 1/4 and 4 cancels off, and you get minus 1. So y is equal to what? You take the negative 2 onto this side, 1/4 x plus 1. So this is an equation of a straight line. You can see that, right? Y equals mx plus b, and that is the equation of the tangent line. So tangent line is a straight line. So we just use this, and then the main thing is, remember, m, the slope is a derivative. All right, that's all for today. All right, we'll see you in class.